Okay, so here we go again. So hopefully you understand now that all these different clues can help us understand what the environment in which that sediment was deposited in the past. So this is all those tools and what I call my, not my CSI, crime scene investigation, but my GSI, my geological scene and scientific investigation. By looking at all the clues within a rock, we can understand its past and understand the processes or what was there in the past. Okay, so we call these depositional environments places where today where sediments were deposited. And if we look in the past or look at rocks, we can see that the deposits or the structures that we see today probably were also in occurrence in the past. So if we see places in the world where we have shell deposits being actively deposited, usually maybe off the coast in a shallow marine environment or maybe in a lake environment or something like that, and we see that a rock maybe out in the middle of Wyoming or North Carolina or something like that, and that exhibits the same qualities as this shell that we see in the modern record, we can then therefore kind of infer that that area had similar depositional environments in the past. Okay, so here's some examples of some depositional environments. We have what we call glacial environments from glaciers, estuaries, which is basically fresh water and salt water mixing together, or coastal areas. So a lot of times we have what we call continental environments, things on the continent itself, okay? Things that we call coastal or shoreline environments, which are interaction right along the coastline. And then we have what we call marine environments, which are off the coast. And we're going to go walk you through each one of these here. So here's some continental environments where we have like lakes, okay, which the transport agents might be lake currents, waves, and precipitates from arid climates where it dries out. For example, you have alluvial deposits where you have river currents, sand and mud. You tend to have arid, humid environments. Okay, desert environments where you have wind and sand and dust, glacial, ice, meltwater. You have shoreline deposits like rivers, like a delta, where the rivers go into the ocean, bringing all the sediment with it. Beach deposit, which is right there, the interaction between the coastline and the ocean itself. Tidal flats, where the tide goes up and down, leaving behind deposits. Then we have what we call marine deposits, like deep sea, where the ocean currents there will deposit slowly sediments at the bottom. The shelf itself, the edge of the continent, where the sediment will fall off the edge of the continent. That's what we call a continental shelf. The reefs, organic reefs, we can form limestones there, and then we call continental margins, okay, which can also get muds and clays and shells and stuff like that. So let me give you some examples here. So here's some continental environments. Glacial environments, alluvial fans coming off of maybe a mountain stream here, rivers like this one here, sand dunes, a lake deposit. This is a picture I took of the Great Salt Lake where I did a lot of my research when I did my PhD. Then we can have transitional environments like shoreline environments for deltas, okay, lagoons like this. We got this one here, tidal flats, beaches, stuff like that. Okay. Then we have marine environments, which is like the reefs here themselves, off the coast here, so the shelf deposits, and then even deep sea floor deposits. Okay, those are all some examples of some. Now, what rocks will actually form in these different environments? Well, we break them down lots of times based off of energy at this point, because remember, energy has a big impact on what kind of rock you'll find in that location. Low energy continental and transitional environments, here's some examples. In the Everglades, if you had a low energy organic locality, you might get lots of coal. Whereas in the Bonneville Flats, that's like the ones that large flat that Jack Sparrow took his boat across, right? You might have lots of salts like halite or gypsum. Or down at the bottom of that would be a good example, or on the bottom of the Great Salt Lake, you might have siltstones or mudstones or clays or shells, things like that. Okay, because it's a shallow water environment where the muds actually slowly will fall down on the bottom of the lake. Okay, or you have low energy environments in marine settings. You might get things like limestones, okay, where that calcite ooze will fall down on the bottom of that shallow marine environment, or a silicous ooze falling down out in the deep ocean, or close nearby you might get some lagoons where you get a lot of coal, right? Okay, so you get some low energy transitional environments. Now, high energy environments tend to have coarser sediments, right? So you have things like Sandstones like this, where you get these old sand dunes, river deposits, beaches. Great example where a sandstone might come from. Or really high energy continental environments, you might get things like breccias or conglomerates, right, where the big particles can't be moved or get left behind. These big particles where you get in river channels, glaciers, and things like that, right? All examples of high energy continental environments. Now there's another pattern that we need to discuss, and this pattern is this concept of transgressions and regressions. These are large scale patterns, and this is talked about in your book, and it's important enough that we need to discuss it. Well, what happens here is this is sedimentary environments or depositional environments will change when sea level goes up and down. So let's say we start off here, okay, in this environment. Actually here, sorry, in this environment where sea level is down. We have a beach environment here, and then some swamp behind it where we're going to form some coal. And then further in, we have these red beds or terrestrial beds, right? Well, as sea level goes up, all of these environments shift inland, right? So as it goes up, they shift inland. So now we have the sand from those sandstones, the clays off the coast, from the shales, then the coals, and then these red beds. And it keeps going up, it migrates inland, so now we have even more deposits on top. Okay. However, now sea level goes down. And if sea level goes down, these environments also migrate. So as they migrate, they deposit on top of it, and you end up with deposits with red beds, coal, sandstones, shales, sandstones again, coals, and then red beds again. And you'll see that in valleys all the time. You see it, it's classic in the Grand Canyon, right? So if you see this sequence of red beds, coals, and sandstones and shales, that means that the sea level is actually going up. But if you see the opposite sequence, where you see shales, sandstones, coals, and then red beds, that gives us indications that sea level is going down. So if we look at the Grand Canyon, there are times when we can see that sea level is going up, sea level is going down, up, and down in multiple cycles, and we see that there. We see that here in North Carolina as well. Sea levels have gone up, depositing sediments, and some of our aquifers need our seats, our feet, went back down, oscillated back and forth, and then right now it's actually a lot lower. It's gone back up because of the ice ages. So the melting of the water from the ice ages, and right now it's continually slowly going up because of global warming. And so that is a process of transgression and regression. Now that's a harder concept to remember, but it's a pattern in the rock cycles that we see that's very important for us to understand. If we can understand this pattern, we can better understand where coal is deposited, we can better understand where oil is deposited, natural gas is deposited, and therefore extract those resources for our use. Now I'm going to go through some review. This last part of this is going to be some review and just some questions to help you understand this. And so we're kind of done with the main concepts of this section, but we're just going to do some review stuff. Okay. So in class, if I did a face-to-face class, I would do these in class, and we do kind of a voting system where they actually figure out which one's the right. We'll talk about who got it wrong or right, stuff like that. We can't do that in this class, but we're going to review it anyways to help you understand this. So which of the following is affected primarily by the type and distance of sediment transportation? Okay. Which of the following is affected primarily by type and distance of sediment transportation? Okay. So the more the sediment is transported, the more sorting occurs. Okay. So because it doesn't, composition will kind of be impacted by this, because the less stable materials tend to actually break apart early in the transportation process, and the more stable materials will be preserved over time. But usually the best example of this is sorting. The more sorting you have, the more transportation you probably have had over time to sort the materials out. Okay? Okay. So what type of sediment is most commonly deposited in the middle of a lake? Now, the middle of a lake would be a low in energy environment. So it's going to be places where the high energy stuff, like sands and gravels and boulders, would be deposited in places like rivers and glaciers and things like that, where you have the bigger stuff left behind, right? Or maybe even in a beach deposit. Whereas clay, out in the middle of the lake, and sediment slowly coming down out of the lake's surface, the water column, sorry, it will fall down to the bottom and form these nice little clay layers at the very bottom. So clay would be a good example for that one. What is the name of the process for the migration of shoreline in a seaward direction as sea level drops? So as sea level drops, you're going to have this sequence of red beds, coal, sandstone, and then shell, right? And so as it goes down, and so you'll have, this would be what we call a regression. So how do sea sediments end up on the tops of mountains? Well, this we'll talk about more later, but often what we'll have is these old shallow seas and stuff like that, and tectonics occurring, forcing that sediment on the very top. It does not mean that because on top of Mount Everest, for example, which is the tallest mountain in the world, guess what? You find limestones with actual fossils in it. Well, how does that happen? Did we have an ocean that tall at one point? No, we didn't. What we used to have is a shallow sea that got, because of plate tectonics, got pushed up into the mountain on the top, right? So these are formed over time in these marine environments, and then they become part of this big mountain range. Okay? So, good examples. Here's our sedimentary forensics again. Rounded sediments probably means that it's had some river deposits. Red deposits in here, probably a terrestrial environment because it has oxidation, right? Notice there's lots of different sizes here. Hasn't had a lot of mature systems, so this is probably not very far away from its source. Okay, and so we'd call this a conglomerate. Okay, not a very well sorted conglomerate, but it's a conglomerate. This one over here, notice has lots of particles, and they're all jagged, so they haven't gone very far from the system. So we'd call this a breccia. Okay, this one down here is very, very fine grained, fissile, even layers in it, so it probably was deposited by some kind of water system, probably clay particles or maybe silts, so maybe at the bottom of a lake or a shallow ocean. Okay, so so here's a sequence here where we have coals and shells at the bottom, coals and limestones, and then that sequence goes over again, right? So this is saying that our sea level is going up and down, up and down. So this would be a great example. This would be along a coastline for that possible sedimentary environment, right? How about this one? You have gravels and sands, gravels and sands. A great example of this, there are lots of them are going rounded. In here, there's some layering within it. This would be a good example of a beach deposit where all that sand is in the same place. But this is a high energy beach deposit because guess what? We have lots of quartz, gravels, and lots of different sands. So maybe the source is really nearby. This is a great example of what we call a ripple mark. And this suggests that we have currents. So a good possible sedimentary structure is maybe rivers or maybe even along the coast in the ocean. Here's a trace fossil. What does it tell us about the environment? Well, it can tell us a lot of different things. It can tell us about the environment of the organism, the mud there. This is how heavy the organism was and so forth. Anyways, so these are all things that can help us. This is our end of our slideshow for the sedimentary process. I hope you learned something. If you have questions, shoot it to me either multiple different ways. You can do it in the general discussion board. You can shoot me an email through just our regular email. You can put it in any of those aspects. I'd almost rather you do it in a general discussion board if it's a question about the lectures, because then you can ask questions about what I talked about here and other people can see it as well. Anyways, talk to you guys later. Hope you enjoyed it. Like I said, this subject, sedimentary rocks, is sometimes harder for people because there's a lot of aspects to it. But it's very useful. I mean, if you can understand how to read sedimentary rocks, you can make lots of money because this is where the oil industry and the natural gas and coal industry wants you to know. If you can understand this, you can make lots of money. Anyways, guys, talk to you guys later.